Hello and welcome to this online lecture about classifying a reaction as endo or exothermic. So endo and exothermic are both terms that we use in chemistry to describe how energy is, the direction that energy is moving in a certain change. So let's just start with the two terms. The prefix endo, there is an N in endo. The prefix endo means in or into, and the prefix exo means out. And the thermic, that looks pretty familiar, doesn't it? It's like the same root as thermometer or thermal, basically refers to heat energy. So endothermic basically means heat energy in, and exothermic basically means heat energy out. So that's basically what the two terms mean. So what you need to learn by the end of this lecture is what kinds of evidence can you gather about a certain change or chemical reaction that will allow you to choose correctly which one of the two is happening for that reaction. We're going to start off really simply, just with what it would feel like if you could feel the reaction happening. Like, let's say you were running the reaction in a test tube and then you felt the test tube. Because endothermic means that heat energy is going into the reaction, the heat energy has to be coming from somewhere. So if this is a test tube and there's a solution, we mixed two solutions in there and there's a chemical reaction happening inside here, and the heat energy is coming in, that would make it endothermic. So what does that mean then if you touched it? Well, the heat energy that's going in has to come from somewhere. If you're not touching the test tube, then the energy is coming in probably from the air surrounding the test tube. But if your hand comes up and touches the test tube, oops, my pinky kind of looks weird. If your hand touches the test tube, then the heat energy is going to come in from your hand. And so if the reaction is drawing heat energy in from your hand, that's going to feel cold to you. So endothermic reactions, if you can touch them, if it's safe, if you touch them, they should feel cold to the touch. So if you run a reaction and you touch the test tube or the beaker that it's happening in, and it feels cold to you, then that is telling you that what's happening inside there is an endothermic reaction. And so then, I mean, clearly then the reverse would be true of an exothermic reaction. If I was running a reaction in a test tube, I had maybe a solution, or I dropped a metal in some acid or something like that. If the heat energy is coming out of that, the heat energy is going to go to whatever matter is touching the test tube. And so if you touch the test tube with your finger, just draw a finger this time, and the heat energy goes into your finger, that's going to feel warm or hot to you. So this is an exothermic reaction. And since the energy is going out, if you touch it, it'll go out into your finger, and then that's going to feel warm or hot. So endothermic feels cold. Exothermic feels warm or hot. So that's, I like to call that the touch test. If it's safe to touch, you can sometimes touch to see if the reaction feels cool or hot, and that can tell you whether it's an endothermic or an exothermic reaction. Sometimes the energy change isn't significant enough for it to actually feel dramatically hot or cold. So sometimes it's really kind of difficult to tell by the touch test. So let's switch gears now and go to kind of a mathy way to tell. We just learned about heat of reaction. Heat or enthalpy of reaction. And you probably noticed, since you had to master it, that sometimes heat of reaction was positive and sometimes heat of reaction was negative. So if you think about heat of reaction, it's an energy change in terms of the system. So if it's positive, that means that you're adding energy to the system. And if it's negative, that means you're losing energy from the system. And so if you're adding energy to the system, then energy is going in. And if you're losing energy, then energy is going out. And so now we can apply that to the terms that we just learned. A positive heat of reaction means energy is going in. That means it's an endothermic reaction. A negative heat of reaction, a negative enthalpy of reaction, means that the reaction is losing energy. Energy is going out of the reaction, and that makes it an exothermic reaction. So if you have a heat of reaction, if you have that number in front of you, it's really easy to tell if a reaction is endothermic or exothermic. It's just whether the heat of reaction is positive or negative. So what do you do if maybe it's not safe to touch the reaction, or you really can't feel anything, and you don't have the heat of reaction in front of you, and you don't really, you can calculate it, but maybe you don't trust it. You want to test it yourself. Well, there is a device you can use to actually measure how much energy is going into or coming out of a reaction. And that device is called a calorimeter. Let me make sure I spelled that right. C-A-L, yep, I did spell it right. Okay, good. So a calorimeter, I mean, we can actually make one in class. It's basically you have some insulated vessel, like you could use a styrofoam cup. So say this is a styrofoam cup right here. Okay. And then what you would do is you would fill it with water. And then you would put another vessel in the water. And this could be just like a metal container or something like that. And that's where you would run the reaction at. And then you'd cover the whole thing, make it harder for energy to get in and out of it, and you'd stick a thermometer in there. And so basically what you would do is you would be measuring the temperature of the water as the reaction happened. And so it should be pretty clear to you how this could tell you if a reaction was endothermic or exothermic. If the reaction happens and it's exothermic, then energy is going to come out into the water, because exo means out. And if energy comes out into the water, that's going to raise the temperature of the water. On the other hand, if the reaction is endothermic, then it's going to be taking heat energy in. And where is it going to get that heat energy from? It's going to get it from the water. So if it's endothermic, then the heat energy is going to go into the reaction from the water, and that's going to drive the temperature of the water down. So if you're using a calorimeter, an exothermic reaction will raise the temperature in the calorimeter, and an endothermic reaction will lower the temperature in the calorimeter. And so that's a way that you can actually try to experimentally check to see if a reaction is endo or exothermic. So there you go, 3 ways to determine whether energy is going into or out of a reaction, whether it's endo or exothermic. Make sure you understand those 3 ways and maybe practice identifying reactions using each one of the ways a few times, and then you'll probably be set for the mastery quiz. That concludes this online lecture. Thanks for watching, and as always, if you have any questions, feel free to ask in class.